sequence. And what does that mean again? Arithmetic means a sequence that's built on what? Addition. We just keep adding the same thing, right? So built on addition. We have two equations. We have the equation for that, and we have an equation for this. This, of course, means what? What does it mean?
Any number.
The nth term. Any number you want where you pick the n. So the nth term I like. So this is the nth term. Okay, so to make n3, it'd be the third term in the sequence. I like it. So an, we did this equation earlier today already. You start at the first guy, and you go up one less step. Cool? And what's kind of funny is it's actually very related to a formula we use in statistics. And I always try to, whenever I teach statistics, I try to get my students to be able to read the equation in English. How do you get to this term? You start here and you go up this many steps. I can read that in English. It's crazy. What was this guy? Remember this is the one we did right at the end of class last time that dealt with the urban legend of math. Nobody got killed, thanks for it.
You sum up all the terms one to one.
It was you take the first term and you add it to the last term, the nth term, and you're going to have this many pairs of that repeated sum. That was the idea. So remember that was when Gauss had to add, recall. Had to add 1, 2, 3, up to 100. And the teacher thought that would keep them all busy. And cocky little Gauss came up and said, yeah, teach, give me something harder. Because all he did, instead of doing 1 plus 2 is 3 plus 3 is 6 plus 4 is 10 and taking forever, he just went 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101, and you're going to have 50 of those pairs, of course. You got 100 numbers. When you pair them up, you got 50 pairs. So all he did was 50. 100 divided by 2 is 50, times 101 is that repeated sum. So that's where you got 50-50, which I like by itself anyway. 1 through 100 adds up to be 50-50. You guys remember that if you were here? If you weren't here, I taped it. Or come see me. Uh-oh, you still don't remember that? All right.
I remember.
So let's look at that problem you're talking about. Look at number 74. Oh, let's see, where can I put this?
On what page?
In section 5.7, it's, 295. So this one says, find the sum of the first 50 multiples of 3. The first 50 multiples of 3. So a really good idea, when they give you, kind of like in words what a sequence is, write a few elements of the sequence out for yourself. Right? That kind of seems like a good idea. Let me see what the sequence looks like. So what's the first multiple of 3? 3. That's the one you got to be careful. Don't skip 3 itself. So 3, careful now.
9,
No,
6.
6. Multiples of 3. So 3 times 1, 3 times 2, 3 times 3. So what kind of a sequence is this?
Multiples of 3.
No. Yeah, I keep adding 3, right?
Yeah, plus 3 plus addition.
So if I say count by multiples of 10, you go 10, 20, 30, 40. I'm not multiplying, I'm adding 10. So be careful. When you see the word multiple, that's what I thought might throw some of you guys off. If you see the word multiple in the question, you might think automatically multiplication. You actually do multiply 3 times 1, 3 times 2, 3 times 3, but how far apart are they all? 3. The common difference, right? So somebody help me out here. What's A1? 3. And what's D? 3. Very single-minded sequence here, right? And they asked me for the sum, but the mistake people make is you try to do the sum formula. You don't even have enough information yet. So the mistake people make on that problem is they do this, they take the sum formula, which is this guy, and they put in there 50 over 2 times 3 plus 50. That is a mistake. What mistake did somebody make?
50 isn't the final term.
50 is not the final term, right? If I go the first 50 of those, I'm not going to stop at 50. I'm going to stop way beyond 50. And here's a quick way to figure out what it is. Some of you guys probably already know. What's the fourth term? What's the fourth term? 12, which is 4 times 3. So what is the 50th term? 150. Right? 50 times 3. Or, you can do this guy. AN equals A1 plus N minus 1 times D. Right? Because I want the 50th term. So if I want A50, that's going to be 3 plus 50 minus 1 times 3. Well, 3 plus 49 threes is 50 threes, which is 150. Any way you do it, you're going to get 150. So the bigger point to make here is, if I ask you to find the sum of something, you got to first figure out what that nth term is before you can use the sum formula, right? Because that's what this guy needs. People just stick n in here. Does this say n? No, it says an. So I need that last term. There's always a two-step process when I ask for the sum. You got to find out how far you're going to go. What's that last term?
So is it 3 plus 150?
No. What's 50 minus 1?
It's 49.
And what's 49 times 3? 147. So then that makes 150. And another thing that comes up here is that there's always more than one way to look at a problem. Did I really have to do that equation for this problem? No. The fourth one is 12, which is 4 times 3. So obviously the 50th one will be 50 times 3. Because they are multiples of 3. There's a quicker way to get it. I don't have to do this, but thankfully this gives me the same answer. Thank God. If it didn't, we'd have to throw it out.
And so the reason you put 50 in the nth position was because it asked you the question of the first 50.
Exactly.
That's why you put it there.
I want to go after the 50th term. So what should go here? Not 50. 150. That's the 50th term, right? 150 is the 50th term. Cool.
So 50.
So if I want to find S50, I could put a 50 here because that's n. I got 50 numbers, so how many pairs will I end up with? 25. You guys see that? If I pair them all up, I'm going to get 25 pairs. Start at 3 and go to 150. That's the last term, right? So if I did this, what I do, 3 plus 150 is 153. 6 plus 147 is 153. And step in, right? That's why you've got to know what that last number is. You don't just put 50 here, you got to put the last number in there, of course. That's how we built that equation up.
Okay, I don't understand on this question here. I know where you got the 150 from.
Sweet.
I know what A1 is. A1 is 3.
I love it.
The fraction is 50 comes from the problem suggested, but why is it over a 2?
Because that's the formula. And again, a better answer than that's the formula is, if I have 100 numbers and I pair them all up, how many pairs will I get?
50 pairs.
So that's why you divide by 2, because you're pairing them all up.
Okay.
Okay, cool. So the simple answer is that's the equation. I mean, but where the equation come from is an easy idea. We paired them all up.
So in order to figure out,
So now I got 25 pairs of the sum 153, right? And then whatever the hell that is.
so why did that wind up to be 150 on that answer?
Because it's the repeated sum. That is 150 the last term, but what's the first term? 3. So what sum gets repeated? 153, 153, 153. How many times? 25 times, because I paired up 50 of them. Cool. And I don't know what that is.
38.25.
Was it
38.25.
38.25? All right, so there's a freebie.
But what's 38.25?
Yeah, what is it physically? What is it? So you're like, that's what I just asked you, Jeff, but what is it? That is the sum of the first 50 multiples of 3.
So the end, the end underneath the 5 represents the end. There.
Yes, the nth whatever. So in this case, the 50th sum. So as I add them up, it's the sum of the first 50 terms. Right? Okay. Cool. That's the kind of problem I expect the question on, because it seems easy when you read it, but you got to be careful how you set it up. And you really should write a few examples for yourself from the sequence so you can see what it really is. Okay. Well, that one excited some of you guys. Any other questions? All right, so let me finish 5-7 up. We have two more equations to talk about because we have one more kind of sequence in this section. And then I'm going to have you guys working some stuff together. So we've got we got this here, just to write this again, and we got this here. And that's, of course, for arithmetic. So now let's talk about geometric sequences. And since we've kind of gone through the idea behind the arithmetic, geometric should be actually pretty easy coming off the work we did to get those equations. At least the first part of it is. So for example, let's do an example here. So geometric is going to be based off of multiplication. So for example, if I had 2, 6, 18, 54, you can pretty quickly eliminate that as possibly being arithmetic. Here I added 4 and then I added 12. Okay, it's not arithmetic. So it might be geometric, and I know it's geometric because what do I keep multiplying by? 3. So the same idea as before, and let me go through it a little bit quicker. A1 is 2. How do you get to A2? You take 2 times 1, 3, right? That's how you get to 6. So it's the same idea of stepping, right? How do I get to A3? I take 2 times 3 times another 3. So 2 times 3 to the second power. And this, of course, is an understood first power there, right? How are we doing so far? Does that make sense? Because I just keep multiplying by 3, so I keep accumulating more and more 3. So incredibly enough, A4 will be 2 times 3 to the third, because I get 1 more 3. So you see the same idea coming out. The exponent is always 1 less than this. Sort of like that n minus 1 we had to put there, right? So I start at 2. I multiply 1 3 to get to term 2. I multiply 2 3s to get to term 3. I multiply 3 3s to get to term 4. So what's an going to be? I start at 2 and I multiply by how many 3s?
Minus 1.
n minus 1. Beautiful.
Or, wait, why is there an equal sign there?
Because
Or equals 2 to the third, 2 times 3 to the second,
2 times 3 to the n. Oh, here?
yeah.
Oh, yeah, I just wanted to show that I have this in multiply by 1 more 3. Those, of course, make 3 squared.
Because it's minus, see how,
Okay.
it's A4 equals 2 times 3 to the first power.
So this should sound very much like last time.
To the term.
Except last time we just kept adding the same thing. But of course, if I start in the first guy, I got to take 1 step to get to the second guy, 2 steps to get to the third guy. It's always offset by 1. Same thing this guy has, the same problem. If you start at the first guy, you take 1 step to get to the second guy, 1 step, 2 steps to get to the third guy.
Okay.
So how many steps to get to the nth guy?
And
1
there's
less.
Oh, okay.
So people get all hung up over this n and this n minus 1, but how else do I tell somebody this is always 1 less than that? Quickly.
You're already
Isn't that
If that's n, that's n minus 1. That's the quickest way to tell somebody that's always 1 less than that.
So,
And that's the usefulness of algebra.
in that sense, the 2 times 3 is 6.
Yeah. And 2 times 3 cubed would be 2 times 27, so the fourth one is 54, thank God. Right? So how do you get